Good morning, students. This is Murthy, sir. Carbon being a versatile element, it shows some unique properties. Today, let us learn about allotropy, an important property of carbon. Allotropy, the existence of a chemical element to two or more forms, which may differ in the arrangement of atoms in crystalline solids or in the occurrence of molecules that contain different numbers of atoms. The allotropes of carbon are classified into two types, amorphous forms and crystalline forms. The word amorphous is opposite to crystalline. Different amorphous allotropes of carbon are coal, coke, wood charcoal, animal charcoal, etc. Now let us learn about crystalline allotropes of carbon. In crystalline forms, the carbon atoms can arrange themselves into different hybridized chemical bonds. Therefore, they exhibit different physical and chemical structures such as diamond and graphite. Carbon in solid phase can exist in three crystalline allotropic forms. They are diamond, graphite, and Buckminster fullerene. Now let us learn about diamond, the hardest material in nature. In diamond, each carbon atom undergoes in its excited state sp3 hybridization. Hence, each carbon atom has a tetrahedral environment. The three-dimensional structure of diamond you can see here. In diamond, the carbon-carbon covalent bonds are very strong. It requires great amount of energy to break them. That's why it is the hardest material in nature. Students, you all know diamonds are very costly and they are normally used in ornaments for attraction. They will be very shiny and attractive. As diamond is a crystalline allotropic form of carbon, you will find luster, that shiny nature. That's why it is used in ornaments. Now let us learn about graphite. Graphite forms a two-dimensional layer structure with carbon-carbon bonds within the layers. These are relatively weak interactions between the layers. These are called London dispersion forces. In the layer structure of graphite, the carbon atoms are in a trigonal planar environment. This is consistent with each carbon atom in sp2 hybridization. In this picture, you can observe two-dimensional structure of graphite and the individual layers are held together by weak attractive forces called London dispersion forces. Buckminster fullerenes are molecules of varying sizes that are composed entirely of carbon. The arrangement of these molecules leads to the form of a hollow sphere, ellipsoid, or tube, depending upon their orientations. Fullerenes are formed when vaporized carbon condenses in an atmosphere of an inert gas. The spherical fullerenes are called buckyballs and they have soccer ball appearance and they are represented by molecular formula C60. In this picture, you can observe the structure of Buckminster fullerene. Carbon nanotubes are considered one of the strongest materials known to man. Carbon nanotubes possess unique structural and electrical properties that make them ideal for a wide variety of applications. Carbon nanotubes are of two principal forms. They are single-walled carbon nanotubes and multi-walled carbon nanotubes. Although not a hollow tube, carbon nanofibers represent a third type of tubular structure. Carbon nanotubes are good conductors of electricity like graphite. They are used as conductors in integrated electric circuits instead of copper. Carbon nanotubes were invented by Sumio Lee-Zima, a Japanese scientist. In this picture, you can observe the two-dimensional structure of graphite and three-dimensional structure of diamond. In this picture, you can observe the geodesic structure of fullerene molecule, and in nanotubes, there will be hexagonal array of covalent bonded carbon atoms. Students, this is a lustrous diamond, and you know, Kohinoor diamond belongs to a country, but during British regime, it was captured by Britishers, and now it is in British Museum. You know very well that pencil lead contains actually graphite, and graphite being a good conductor of electricity, it is used as electrodes in electrolytic cells. Three great scientists, Curl, Croto, and Smalley, they discovered fullerenes. For this discovery, they were awarded Nobel Prize for Chemistry in the year 1996. Here you can see the picture of three great scientists. And nanotubes were invented by a Japanese scientist, Sumio Lee Zima. Here you can see the picture of the great scientist. These are four crystalline allotropic forms of carbon: graphite, diamond, fullerene, and nanotubes.